Hello, welcome back to my channel InfoSec Lab, and this is Hui, and it's another day of the TryHackMe's Advent of Cyber 2024. Now, if you remember 2 days ago, we went over a web application vulnerability, which is the insecure file upload and remote code execution. Today, we're gonna be going over another vulnerability that is very popular amongst web applications, which is known as XXE. So before we get to know this vulnerability, let's get down to some concepts and the learning objectives for this room. The learning objective is to understand the basic concepts related to XML, explore XML external entity, or known as XXE, and its components. Learn how to exploit the vulnerability, and last but not least, understand the remediation measures. So what's XML? XML stands for Extendable Markup Language. It is a commonly used method to transport and store data in a structured format that humans and machines can easily understand. Consider a scenario where two computers need to communicate and share data. Both devices need to agree on a common format of exchanging information. This agreement format is known as XML. So XML is considered a filing cabinet, and then in this cabinets that holds a lot of folders. Within the folder is the data, the documents, which is the data. So over here, you see people, name, address, email, phone numbers. There are tags in XML documents, and then within the tags, we see the values of the tag. So glitch is gonna be the value of the name tag. Whereview is going to be the value of the address, and then glitch at whereview.com is going to be the value of email. And then all of these are attributes of the people tag. Pretty straightforward, right? So document type definition, or DTD. Now that the two computers have agreed to share data in a common format, what about the structure of the format? Here's the DTD. It comes into play. A DTD is a set of rules that defines the structure of an XML document. Just like a database schema, it acts like a blueprint, telling you what elements or tags and attributes are allowed in the XML file. Think of it as a guideline that ensures that the XML document follows specific structures. So for example, in this one, if we want to ensure that an XML document about people will always include name, address, email, and phone number, we should define the rules through the DTD as shown below. So again, the tags are name, emails, address, email, phone number, and then the PC data is right here. Stand for pers people data, meaning that all of these elements is gonna be all of these tags are served as the attributes for this people tag. Entities. So far, both computers have agreed on the format, structure of the data, and the type that data will share. Entities in XML are placeholders that allow the insertion of large chunks of data or referencing internal or external files or resources. They assist in making the XML file easy to manage, especially when the same data is repeated multiple times. Entities can be defined internally within the XML document or externally, referencing data from an outside source. So in this example, as you can see, the entity is name extension. So it's like a variable in coding. So this is a variable, and that is referencing a resource outside from TryHackMe, and then the resource it is referencing is the robots.tag. And here in the XML documents, the variable is used right here. If you want to refer to the variable, you use the syntax ampersand and then the name of the variable, which is the extension right here, followed by the semicolon. Straightforward, easy to. If you're familiar with coding, this should be easy to understand. So what's XML external entity, or XXE? It's a vulnerability where attackers take advantage how a system parses XML documents. Sometimes the inputs are not sanitized and validated, which allows attacker to request to unauthorized to request internal to request resources from the internal system without any authorizations. So for example, right here in this XML document, the entity is named TryHackMe file, and then it's requesting resources from the SC password from the system. It's requesting the resources from the internal system, and then it's gonna be displayed in the address field when parsing the data to another computer. I know the concept is a little bit confusing, and then maybe my explanation is not very clear, so let's dive into the example and see how it goes. Okay, now over here we have the website that was started by TryHackMe. Let's take a look at the workflow of the application and see what it does and how it's built. So we're on the home page. Let's view an item, take the other view, add to the wish list. Okay, there's nothing else. Let's go back to home page. Let's go to the cart. Okay, so we have removed. We can remove it, and then let's go back and try to check out. This time, add to wish list, and then cart. Proceed to check out. Let's see. Haha. And then 1, 2, 3, 4, 5th Street, apartment 6, California 9, 7, 8, 9, 10. Complete checkout. And then wish list successful. Let's see what the wish list is. And then over here, as you can see, now we are not allowed to see the wish list. Only the signer or the admin of the system can view the wish list. So how do we do that? Now, if you notice that I have already run the burp sweep right here, and if you take a look at the proxy tab and the is sub tab from the HTTP history, we can actually investigate on the traffics that we've been doing so far. So remember, first the products right here. Let's get back and see what we did. First, okay, let's go back home. So first we click on the product, so we get the product right here, and then this one is when we add to wish list, perform a post request to the servers, and adding the item to the wish list. And now here we can see an XML document right here. So from this point, this might be a point of interest for us to take a look at and dive further. But before doing that, let's go through all the requests to see if there's anything else interesting. Get request to homepage, nothing else. Post, nothing else. Okay, this is the post request for removing the item. Not really important right now, so let's just keep it in mind. To the cart, still no XML detection. Okay, so far as we can see, only this post request number 7 right here on my screen is using the XML documents to communicate with the server. All right, let's try to explore. Let's try to see if the system is vulnerable to the XXE vulnerability. Let's go back to TryHackMe room, and then we can try this payload right here. No, not this one. Right here. Okay, let's compare. Okay, before now, right click this one and then send it to repeater. This is where we're gonna be modify our payload and to see what the response we're gonna get. Now before, let's paste the payload into the request and see what it does. So basically what we did was just like using a DTD, which is document type definitions, and entity to request the content of the host files in the system. And then after that, we display the contents of the host file into the product ID right here. So let's try it. Keep this one, delete this one, and let's see what do we get. Okay, so we actually got the content of the host file, meaning that the application is vulnerable to XXC. Alright, what's next? We can try with other hosts like SC password, the most interested file in the Linux system. Yep, we've seen a lot of things right here. Cool. Now, our purpose is to view the wish list, which can only be seen by signers or the admin of the application. So how do we do that? How do we leverage the XXE vulnerability to read the content that we're not supposed to read? So one thing to keep in mind that on Linux system, there are multiple places that we want to access and look for information. SC host file is one of those, SC password is another one, and SC shadow is another one. Now when it comes to when there's an application, most of the time, let me put up a note right here. So most of the time in Linux system, the root directory of a web server is located in var/www/html. That's the root folder. So when you go to the home page right here, this is where the index file.php is going to be located. So let's go back to the wish list that we try to access. Where is it? Right here. So we gotta get request wishes and then wish 21 text. Wishes / wish 21.text. Earlier we tried to access this file, which was denied. So we can guess that within this root directory, we have other folders like the wishes, and then we can try guessing that maybe the text file is located in HTML and the wishes folder, and then this is the actual file that we're looking for, that we're interested in. We're not sure, but the default location is going to be like that. So why don't we just give it a try? I mean, in fact, we can actually we can verify this one first. Go to repeater, which is right here, and then try inputting. What we have, index.html. There's nothing. Okay, how about we try this one? Wish 21.text. And we got the results. As we can see, these are exactly the data that I put into the fields in the checkout process. Haha, the name haha, and then 123 5th Street, apartment 6, well, that's a typo. So yep, we were correct about the locations of the file. Now, how do we find the flag? Looking at this file, we said wish/21. It makes me think that maybe I'm the 21st customer landing on the application. We can double check by this theory by trying to make another checkout. Add to wish list, and then go to cart, make another checkout. Let's say haha 2, and then 1 2 3 4 5 6 7th Street, apartment 9, and then California 9111900. Okay, so the latest one, the newest customer is number 22. We can confirm this and see. Number 22. Send it. Boom. So our guesses were correct. Now we can try to go from 1 all the way to 22 and look for the content of the flag, but in real world it's not the most optimal solution. We want to make it quick and fast. That's where the automation comes in. That's where we can use Burp Suite intruder tools right here. So send this one, regulate this one, send to include intruder or Control I on Windows machines and Command I on Mac. Once we send this to the Windows machine, to the intruder, select the number right here, click add, and then the attack tab is gonna be sniper attack. For on the payload tab, we select numbers, and then we're running from 1 all the way to, well, because we already seen the content of 21 22, so there's no point, but you can just put it anyway. Step is 1, and then leave the rest the same. Resources pool is nothing to worry about, skip it. And in the settings, we don't want to go through all the results and look for the flag. That's also not very efficient. The way we do it is just use the grab match. Now we know the flag is, usually when TryHackMe provides you the flag, it's gonna be under the format flag equals, and then it always start with THM capitalized, right? So we can just add those two keywords. First, we remove these preceding keywords, and then add those two, flag, add it. TryHackMe, another one, add it. Now we have two keywords to look at. They should be in the same request. And everything looks good. Let's start the attack. Confirm. And shortly we should get the request that contain the flag. Sorry. It's the text file number 15. Now you can go back to the repeater tab right here, and then click this one and then send again. That's one way to do it. But if you're already if you've already proficient in Burp Suite, you can just select the packet right here, click the response tab, scroll down, same thing, boom, and we got the flag, which is right here. Okay, another place that we also need to look at is the changelog. As TryHackMe has already explained, this location provide all the histories of the commits that glitch made to the application. So if you read here, after discovering the vulnerability, Muscadet immediately remember that the changelog file exists within the web application stored at the following endpoint, the changelog. After checking, it can be seen that someone pushed the vulnerable code within the application after someone's team. So I believe that's where the second flag is found, right here. Yes, it is. Copy. Submit. And we got 2 flags. Alright, speaking of mitigation, how do we pretend or no, sorry, not pretend, I'm sorry. How do we prevent excessive vulnerabilities? Well, there are several ways to do it. First of all, in order to prevent this vulnerability, we have to sanitize and validate user input. So we should restrict, if there are any, we should restrict sensitive keywords like SC password, SC host, or any other sensitive folders that may be requested for access. Also, we have to disable the, what was the other one? The other way is to disable external entity loading. So because I haven't got a lot of coding experience, so I'm not sure how it works in PHP, but over here it says that in PHP you can actually prevent XSE by setting the library XML disable entity loader to true before processing any XML document. So those are the only 2 ways that we can actually prevent the XXE vulnerability. If you know any other ways that I didn't mention in this room, please feel free to put in comments, or if I didn't mention anything, if I said anything that was a little bit incorrect, feel free to let me know. Alright, and that's it for the room today. Thank you very much for watching, and I hope you have a good day. See you. Bye.